Welcome to ET Math Academy. Problem for today is graphing sine function. So here is the function y is equal to 2 sine of 4x minus pi by 2 plus 3. So in my earlier videos I have shown you how to graph the sine function for y is equal to a sine of bx. Now in this video I'm going to show you for the standard format of a sine of bx plus c plus d, where it has A stands for amplitude and B stands for coefficient of x, and B can be used for finding the period of the wave, which is 2 pi by B, and C here is the phase shift, and D here is the vertical shift. So how many units do we need to move the graph up? So for doing this we need to graph the basic standard sine graph, and then we are going to apply the shifts for that basic graph. So how are we going to do this is, so when we compared this with the standard form here, I knew that A amplitude is 2 here and B value is nothing but the coefficient of x, which is 4. So using B I'm going to find my period, which is period is equal to 2 pi by 4 here, B, which is pi by 2. And here I have for the phase shift value, I have it here for the C, I have it here as pi by 2. And for the vertical shift here, I have for the D here, I have it as 3. So I can write down my vertical shift, which is 3. Okay. And as you all can see that there is no negative sign here, so the graph stays on top. So amplitude is 2 and phase shift is 3. And one thing we need to do here is we need to find out the scale here. So I'm going to find it out here, scale for the graph. So the horizontal shift becomes horizontal on x-axis, horizontal shift. So this becomes period divided by 4. So for the period, I got the period as pi by 2. So I'm going to take this here pi by 2 and divide it with 4 parts. Then I get each part as pi by 8. So on x-axis, I take my each unit as pi by 8. And the vertical shift, coming to the vertical shift. For the vertical shift here, we see that we can take 1 unit. So we can graph the axis as like this here. So this is the standard graph here. And so for this standard graph, I'm going to mark my x-axis here and my y-axis here. Okay, and this is origin 0. So as you all can see that the horizontal shift is pi by 8, which means I'm applying that here. So let me mark my first unit as pi by 8 here. So my first unit is pi by 8, and next second point is pi by 8 plus pi by 8, which is 2 pi by 8. When I simplify, I'm going to get it as pi by 4. So it is pi by 4. And for the third, it is 3 pi by 8. Okay. This is 4 pi by 8. So 4 pi by 8, when it is simplified, it becomes pi by 2. This is 5 pi by 8 here again. And here I have 6 pi by 8, which can be simplified as 2 times 3 and 2 times 4, which can be written as 3 pi by 4 here, and 7 pi by 8, and 8 pi by 8 is nothing but pi. And on y-axis, I take the scale as 1 unit each, 1, 2, 3, 4, 5, and let's mark the negative y-axis, minus 1, minus 2, minus 3, minus 4, and minus 5. So this is how you take the scale here. And now let's take the positions and plot the points here for the base graph. So always, to understand the basic sine graph is always in this format, where it's 0, it is 0, and it has the maximum point, and then it comes to 0, and then it goes to the minimum point. So here, as you all can see, that the maximum value is the amplitude, which is 2. So A is the maximum point here, 2. So I can start my standard graph with 0, and at 2 I can place my maximum point, and to the next value on x-axis it will be 0, and to the next value it will be negative point, which is negative amplitude. So it will be -2. So let's draw the graph here now. For the standard points, it will be 0, and for pi by 8 it will be maximum point, which is 2, and for pi by 4 it will be again 0, and for 3 pi by 8 it will be negative -2 here, and for pi by 2 it will be 0. So since the period is here, we got the period as pi by 2. So for one complete cycle, the graph looks like this. Okay, and now I'm going to apply my phase shift to this. So for the phase shift here, I need to move pi by 8 to the right, and pi by 8 units to the right, and 3 units to the up. So vertical shift here is the D. So for the D I have 3. So I am shifting this standard graph. I'm applying the shifts here. So horizontal shift, I have the horizontal shift, which is period divided by 4, which is pi by 2. So let me write the shifts here for you. Horizontal shift is pi by 8, and vertical shift from this formula here is 3. So now I'm going to take this standard graph here and apply the shifts here. So it says pi by 8 units to the right, and vertical shift is always on y-axis, so it is up. So I need to move the 0 point here. So let me change the color. So for changing the color, I'm taking my red pen for applying the shifts. So pi by 8 to the right. So I have my first point at 0, and pi by 8 to the right takes me over here, and I need to apply my vertical shift 3 units up. So pi by 8 to the right, and it is on 0. So 3 units up is 1, 2, and my point becomes here. And this is my second point at pi by 8. I need to move it to the right for pi by 8 units, so it comes to pi by 4. So this point is shifted to the right 1 unit, pi by 8, and it needs to move up for 3 units. So this is at 2, and moving up for 3 units is 3, 4, 5, in 1 unit to the right, pi by 8. And next point is on 0, pi by 4 comma 0. So 1 unit to the right, pi by 8, and 3 units to the up is here. And my next point here is at 3 pi by 8. My standard graph value is at minimum point, which is -2. And now I'm going to move it to the right 1 unit. So it comes to pi by 2. And now I need to move 3 units up. So -1, 0, and 1. So, and at pi by 2, I need to move to the right 5 pi by 8. Pi by 8 units to the right, so it will land on 5 pi by 8. 3 units on top takes me here. So now I'm reconnecting the dots here. So this is the shifted graph for my graph. For my standard graph, I have the shifted graph here. So this is how you draw it, and let me explain the entire thing once again for you. So this is my graph, and I found out my amplitude, phase shift and everything here. And here I drew my standard graph and then the shifted graph. So thank you.